This video is going to take a look at continuing our practice with sets, set notation, and some definitions. Let's start with a subset. A subset is part of a set. All of the elements of the subset must be elements of the original set. We also have an improper subset, which is a subset containing all of the elements of the original set. So if we consider the set A defined as 1, 2, 3, there are 8 subsets of A. We would call A the given universe. What are those 8 subsets? We have 1, 2, 3, 1, 2, 1, 3, 2, 3, and then our unique sets, which are the empty set or the null set and the original set, which is also, curiously, a subset of the original set. The empty or null set is a set with no elements, represented by the empty brackets or a 0 with a slash through it. An example of that would be the set of all students in the room over the age of 18. A finite set is a set with a countable number of elements, such as the set of all students in the school. An infinite set is a set with a non-ending, uncountable number of elements, such as the set of positive numbers. The complement of a set is all of the elements in the universe that are not in the given set. The notation for complement is S with a prime, S with a hat, or not S, whichever letter you happen to be using. We're just considering this one is S. Let's consider the set E, defined as 2, 3, 5, 7, 11, 13, and F defined as 2, 5, 7. What is the complement of set F within set E? Those would be the elements that are in the universe that are not in set F. I think you could pause here and take a look at numbers 2 and 3. In 2, the complement is the set of negative integers. 0, remember, is not negative, but it is whole. In 3, that would be option D. So in question 4, you're asked to use set builder notation to represent the complement. I'm sure you can pause here and try that. Likewise, on 5, you are asked to graph on a number line the complement. So try 4 and 5 and come back and check your answers. In question 4, we're going to represent the complement with our set builder notation. If I look at this, I see A prime is representing the complement of question 4a. X is an element of the reals such that x is less than 4. B prime would be x is an element of the real such that x is greater than or equal to negative 3. And C prime, x is an element of the real such that x is less than 4 but greater than negative 4. In question 5, we can graph the complement relatively easily, just making sure to have an empty circle where there's a solid circle. And then we just continue in an opposite direction. So hopefully those were pretty straightforward. Now we're going to look at some additional terms. We can have an interval that is inclusive or closed, and we represent that by the hard brackets, we call those. And it is an interval that contains all of its endpoints. I think of an interval that contains its endpoints would have the closed dot, or it would be greater than or equal to, or less than or equal to. An exclusive or open interval is an interval that lacks both of its endpoints. It excludes them. So that's our open circle, greater than or less than. There's a note here not to confuse interval notation with a coordinate point. So again, just like in English, math can be contextual. Pay attention to what you're doing. And then we can have a half open, half closed. So that wouldn't be an interval that contains one of its endpoints, but not the other. The example, x is greater than negative 3 and less than or equal to 2, is a half open, half closed interval. And it would be written with the open bracket on the negative 3 and the closed bracket on the 2. So why don't you pause here, take a look at the next several questions on the page, 1 through 4, and come back and check your answers. Question 1 is option C. Question 2 is A. Question 3 is D. and question 4 is C. So that's it. A lot of extra vocabulary and some notation. Why don't you practice on page 12 and we'll take a look at that in class. Have a great day.